Hello everyone and welcome to this recorded session on finding the area of a circular segment. In the previous session, we did use the rule for calculating the area of a circular segment. And as you know, the circular segment is a region bounded by an arc and a chord in the circle. Knowing how to calculate the area of a circular segment is useful in many areas, such as in engineering, mathematics, and physics. And in this session, we'll answer some questions about the rule we did use, and I'll show you some examples to help you better understand the concept. So let's get started. In this example, I want to get the area of the circular segment colored in yellow. The opposite angle is an inscribed angle. We need to find the central angle. So the central angle is the double of the inscribed angle. So the central angle will be 90. Because you know, the central angle and the inscribed angle, if they are bounded by the same arc, so the size of the inscribed angle equals half the size of the central angle. So the central angle here is 90. Theta equals 90 degrees. And theta radian, the same angle in radian, it's pi over 2. Now we need to find the radius. Because this side is given as 10 centimeters and this angle is 45, this angle is 45, and this side is r, so we can use sine 45. Sine 45 is opposite over the hypotenuse. Opposite is r and the hypotenuse is 10. So we can do cross multiplying. The radius is going to be 10 sine 45, which is equal to 5 root 2. Now we are able to apply the rule and find the area of the circular segment. Is equal to half multiplied by r squared. R is 5 root 2 raised to the power of 2. Then theta radian is pi over 2 minus sine theta. Sine theta in degrees, sine 90. By using the calculator, it will be 14.3 to the nearest 1 decimal place, centimeters squared. Find the area of the major circular segment in which the length of its chord equals the length of the radius of its circle equals 12. So here the chord is 12, the radius is 12. So this triangle is an equilateral triangle. Each angle equals 60 degrees. If I want to get the area of the major circular segment, so this angle will be 300. Now we can apply the rule directly. It's half, and then r squared. R is 12 raised to the power of 2 multiplied by theta radian. But we know theta in degrees, so we can convert it into radians by multiplying it by pi dividing by 180 minus sine 300. Then by using the calculator, we can find the area directly. It will be 439 centimeters squared to the nearest whole number. And the opposite figure, BC equals 12 centimeters. And the semicircle M here, it's the semicircle, its center M here, and BC is a tangent. BC is a tangent. And I want to get the area of the shaded part. The shaded part here is a circular segment. How can we find its area? To find the area, we need to find the size of the central angle here. Because this triangle is an isosceles triangle and BC is a tangent, so this angle will be 90 degrees, and this angle 45, and this angle 45. Here it's radius in the circle, and here it's radius in the circle. So this angle is 45, This angle here, which I need, is 90 degrees. And the radius is 6 centimeters. So we can apply the rule because we have the radius. The radius is 6 centimeters, and we know the theta is 90 degrees, which is equal to pi over 2. So what is the area of the circular segment is half multiplied by 6 squared multiplied by pi over 2 minus sine 90. By using the calculator, you will find the area to the nearest 2 decimal places. It's a 10.27 centimeters squared. Let's go to the next example. In the opposite figure, if AB is the diameter in the circle M, then the area of the shaded part equals how many centimeters squared? We need to find the length of the radius firstly, and we know that the inscribed angle drawn in the semicircle is right. So this angle is 90. And this angle is 30, and we know that the length of the side opposite to angle of measure 30 equals half length of the hypotenuse. So the hypotenuse is going to be 20 centimeters. So the radius is 10 because the hypotenuse is the diameter. So radius is 10 centimeters, and we want to find the angle. We have here the inscribed angle opposite to the circular segment. If we are going to draw this line here, so we'll get the central angle which we need. This angle will be the double of the inscribed angle, because the inscribed angle is half the size of the central angle if they are suspended by the same arc. So this angle is 60. So theta equals 60 degrees. Now we are able to find the area of the circular segment is half multiplied by 10 squared and theta radian. We have theta in degrees, so we can convert it into radian by multiplying by pi over 180, then minus 60. By using the calculator, it will be 9 to the nearest whole number, 9 centimeters squared. In this example, if AB and AC are two tangent segments of a circle M, measure of the angle between them is 30, as you see, and AB is 5 centimeters. Then the area of the shaded part. The shaded part is a circular segment. We need to find the radius length, and we need to find the size of the central angle. And we don't have any of them. So here we have a radius and a radius. And the radius is perpendicular to the tangent. So this angle is 90, and also this angle is 90. ABMC is a quadrilateral. So the sum of its interior angles equals 360. So measure of angle BMC equals 150 degrees. Now we need to find the radius. To find the radius, just draw a line here and focus on this triangle. The line joining between this point and the center of the circle divides the quadrilateral into two congruent triangles. So this angle is going to be 15. Tan 15 in this triangle is opposite. Tan 15 is opposite R over the adjacent. The adjacent is 5. So what is R? R is 5 tan 15. By using the calculator, we can find the length of the radius. So the radius equals 1.34 centimeters. Now we can apply the rule to find the area of this circular segment. The area is half multiplied by radius squared, which is 1.34 raised to the power of 2. And theta radian, this angle is 150, so 150 multiplied by pi over 180 minus sine the central angle measured in degrees, sine 150. It will be to the nearest one decimal place 1.9 centimeters squared. In the opposite figure, ABCD is a rectangle. E is the midpoint of AD, and AE equals ED equals 6 centimeters. A circle is drawn with a center B. A circle is drawn with a center B. Passes through the point E and C. Passes through the point E and C. Because the center of the circle is B, so EB is equal to BC. All of them are two radii in the circle. Find the area of the shaded part. The shaded part is a circular segment, so we need to find the size of this angle here. So this is a radius, and this is a radius. So this angle is equal to this angle. The shape ABCD is a rectangle, so the length of BC is equal to 12. And also the length of BE is equal to 12 centimeters. If we focus on this triangle, you would find that the length of this side is half length of the hypotenuse. So this angle is equal to 30 degrees. And because the shape is a rectangle, so the size of this angle is 60. And the triangle EBC is an equilateral triangle now, because this angle is going to be 60 and this angle is going to be 60. Now we can find the area of the circular segment. It's a half multiplied by 12 squared and multiplied by theta radian. We have theta in degrees, so converted into radian by multiplying by pi over 180 minus sine 60. By using the calculator, you will find the area 24 pi minus 36 root 3. I hope you enjoyed this session. See you in the coming episode. Goodbye.